To help restore a beach, sand is being added to the beach at a rate of st. Okay, that's my rate. S of t equals to 65 plus 24 sine a point, whoops, 0.3 t tons per hour. Okay, thank you. Where t is measured in the hour since 5 a.m. How many tons of sand are added to the beach over the 3-hour period from 7 to 10? Okay, great. So for us to talk about cumulative change, we're just gonna take the integral. If this is the rate of sand, we're gonna just take the integral from 7 to 10. Now, if you put 7 to 10, that's gonna be wrong because unfortunately the way that it's phrased is that t is measured in hours since 5 a.m. So at 5 a.m., that counts as 0 hours. At 7 a.m., that counts as 2 hours. And at 10 a.m., that counts as 5 hours, right? So we're going to plug in from 2 to 5 in there, okay? And then so we're going to plug in 65 plus 24 sine of 0.3 t, the t dt. And on your calculator, remember you plug this as a dx value, okay? So let's go ahead and bring myself to my other, let me log into my other device right now. All right, so I'm now on my graphing calculator. I'm going to go math 9. Remember, if you memorize that math 9 from 2 to 3, or 2 to 5, I'm sorry, 2 to 5, 2 to 5, yep. And then we're going to write the 65 plus 24 sine of 0.3 x, close it, and then close it, and then x. Okay. We have the answer 255.368. So that says my answer is going to be A. Let's make sure we read the question just in case we were tricked in any way. How many tons of sand are added to the beach? Yep, because we're adding this much sand. Okay. Oh my gosh. Do you want to give a career a fresh start? Huh? Do I? Stupid text. That's all I get. Okay, here we go, number 11. F be the function of the first derivative. Okay, they gave us the first derivative, great. And then they told us between 0 and 2, at what value of x does f attain a maximum value on the closed interval from 0 to 2? Okay, so when you're looking for maximum values, we're going to look for critical points. And those critical points, we're going to check if that's a maximum. And then we're going to also check the endpoints. You always have to compare the endpoints because we're not sure where you started off from, right? So maybe you might end up with a graph that looks like this, right? Sorry, let's a graph that looks like this, right? And you see, oh, hey, look, that's a nice critical point for us. That's when the derivative is equal to 0.
Mr.
But
Ko,
then, what?
was it a bad idea just to plug in each of the numbers they gave us into the sine cube?
You could, like if you plug in the 0, the 2, right?
Yeah, basically the numbers they gave us, I just put each one of those into where the x was, and then I got the highest one from there.
That is, I mean, it's a multiple choice strategy, right? You could try doing that,
Yeah.
right? But what if one of these numbers was a fake number that was outside, like it was, wait, never mind. That wouldn't be true because all these numbers here are between 0 and 2, right? It's all between 0 and 2.
Yes.
Gosh. Let me see. If f is the function first interval, what is the value of f? Okay, so what happens is, okay, fine. You could do that, okay? But I feel like there could be some bad voodoo that happens there, but probably not then. So I'm gonna actually just graph it. I'm gonna graph that and look for the zeros. Okay, so let's go and graph it and look for the zeros. Let's go and jump to my other screen. Share my screen, share now. Okay, so I'm gonna go y is equal to, and then we're just going to type a very simple sign of x cubed. Okay, and then we're going to graph between 0 and 2. So I'm going to go ahead and actually change my window. You don't have to. I'm going to change my window between negative 0.1, I guess, and maximum of 2.1, right? Just so I'm covering my little corners here. And graph it. And all I do is I care about the zeros. Okay, so you can see the zeros happening. Looks a little hard to see, so I can change my x and y. So my y value, so my y min is -2, my y max is 2. Let's graph it again. Nope, darn it. Whoops, I flipped them around. This would be -2, and the y max is 2. That makes it a little bit easier to see. Okay, so I'm going to go ahead and now look for the zeros. So second calc, zeros is 2. So we have a 0, sign of 0 is 0, we know that for sure. And then over here we have another 0 on the right. Here's our next 0. And that 0 happens at 1.464. The second calc 0 is left bound, right bound. I'm just telling you guys where the zeros are. You can skip some of this actually. Honestly, you can skip some of this. 1, 8, 4, and then the last one is, okay, then that's it. So I only have 2 zeros here. 1.464, they have that one. Then they have one at 1.162. 1.162 is not a 0 in this graph. Okay, so drawing a number line here. Looking at the slope here, I want you guys to see where would we have a maximum. So let's discuss this graph. On the left side here, right when we leave 0, see how it's a positive slope? That means we are making money, we're increasing. So we have a positive slope, increasing, stop increasing, 0, negative. So we have at least a relative maximum here. And then, so we have relative positive to negative, and then back to positive. Okay, so let's go back to our other screen now. Let me take over from the other screen. So, darn it, it went away. So we had declared some numbers already. It was like, here's a number line. Let's talk about how to do this wrong. We have 1.465 and 1.845. These are our two numbers. The slope was the graph. The derivative graph looks something like this. Okay, at 2, here's 2 and here's 0. Now, because the graph is positive slope here, we know we are increasing. So positive, negative, positive. So if we do have a maximum, it's going to either appear here or here at the end at 2. Why is it? Because we're walking up to 2, right? We're crawling up to 2. We have a max because we go from up to down. So we have a critical point there, maximum, we have a maximum there. Okay, so at only 2 places that we have to check with this. So so the f of the function, blah, 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 at what values of f does f attain a maximum on a closed interval here? So if we go back and look at the graph, actually, let me ask you guys, at what point do you think we're going to end up with a maximum? So if you look here, we gained a lot. So we gained a lot. So we should be like, wherever we started, we should be way up here. We lost a little bit, okay? We lost some. But then, did we gain all that back? No, we didn't gain all that back. So even though we came back up, it wasn't as high as our maximum. So this could be done by just looking at the graph. And the answer is this guy here. If they want actual values, they would have given us more information. Like right now, we don't know where the graph initially starts. They give us the f prime graph. But we can look by looking at our graph here, we can say, hey, we gained a lot here, a lot of gain, a little bit of loss. That's loss. And then we only gained a little bit back. But it wasn't enough to cancel. It wasn't enough to cancel out this. It wasn't enough to cancel that out. Now, if this graph was drawn slightly different, if I just show you the graph, and the graph was a big gain, a little loss, and then a gain like this again, let's say this was the graph. Big gain, this is gain, this is loss, and then gain. So looking at this graph, our actual maximum, absolute maximum would have been actually here. This would be that max. So if I want to attribute money to this, this is $10 minus 1 plus 3. So where's your maximum? At 10 or at 12? It would have been 12, right? That's one way you can look at this. So this could have been a really fast problem. I just made it really long. But finding these problems here, these points here, that's simply setting your calculator by calculating 0. So you know what those numbers are. So when you look at your multiple choice, you see that, hey, 0.162 is actually not an answer here. That's actually a false positive. So this was not going to be a max because we had a positive slope, so we left a low position. This was a possibility, this was a possibility, this was a possibility. Turned out that was not a possibility because the slope went from a negative to positive here. It dipped, we lost some value. So we only had choices here and here. We gained a lot here and we didn't gain enough money to make our money back. Sounds like crypto right now. Haruka, you okay with that?
Yes, I just didn't graph it.
Oh, you didn't graph it? Oh yeah, graph, because remember this is a calculator problem, so we can graph it. So it was super helpful. And the hard part is reading that graph, understanding that's my, not, oh, do you know what probably happened? This, when you looked at the graph, actually this point here is probably the 1.162 maybe. That's like this point here. So if kids saw the graph, oh, hey, that's my maximum. Like, oh, that's a maximum value, but that is not our F value. This is our derivative. That's probably what this point was here. Okay, can anyone else have any questions about this here? No? So I just do random problems on this test then? Okay. If not, hey, Bobby, you had another question? Sorry, Bobby. Oh, number 3, for sure. Let's go ahead and take a look at number 3. Okay, now one thing about these questions is that people are like, oh, the calculator section might be easier. Well, no, because now you have a calculator, right? And that means they can give you more difficult questions with like decimal answers, or you have to graph and analyze graphs. So that's why I feel like sometimes the non-calculator section is actually easier, because now they can give you a ton of worms here because they say, hey, you have your calculator. Okay, here we go. At t is equal to 0 minutes, a tank contains 40 gallons of water. For t between 0 and 4 minutes, water flows into a tank at a rate of 12t sine blank gallons per minute. The water leaks out of the tank at a rate of that. Okay, how many gallons of water are in the tank after 4 minutes? All right, so we said we start off at 48 gallons, okay? And then we're going to add water, and we're going to add water at a rate of 12t sine of pi over 4t, right? We're adding this water to it. And then, but even though we're adding, we're also subtracting. So between 0 and 4, we have a equation that says, hey, you're gonna lose this much water. Okay, and that's really how much is in the tank, right? How many gallons are in the tank? So we take our starting, then we add, and then we subtract. Okay, and that actually just all goes in your calculator. Let me go and take it over again. The transition is slow, I'm sorry. So, not that one. Okay, so we're gonna do math 9. So make sure you know math 9 already. Oh, darn it. I should have said 48 plus math 9. And then we're going to go from 0 to 4. Now you practice your calculator, so you're good with doing this quickly. 12t sine parentheses pi, second pi over 4t. So they gave me a parentheses there already. Oh, that's probably not going to work out well. Will it work out well? Nope, I don't trust it. So I'm going to put a parentheses there and the second pi. Insert parentheses, close that parentheses. Parentheses, close parentheses. I think that's enough.
Was it a pi or x?
You're right. It wasn't pi. It was a x. You're right. Pi over 4x. Close 1, 2, 3. Yep, I think that's enough parentheses to close it. We're gonna throw an x there, and then another plus. No, this time minus. I'm sorry, minus. So because we're subtracting it, math 9 again from 0 to 4 of. I'm gonna do parentheses 6x squared divided by tx plus 2. And if I cross my fingers, I didn't mess up any of my parentheses. We end up with 82. And that's our answer. Okay. Okay, and that was our answer right here. That was our B answer. So the problem was not hard in the end. It's just you just needed to know what to plug in. Okay, Bobby, how was that? Was that helpful? Okay, does anyone else have any other questions for me?
I forget the number, but it's like f of x is equal to the derivative of. Oh, I can't.
Okay, I'm just gonna go through them. You tell me when you see it.
It's that one.
Oh, this one? Okay.
Yes.
Perfect. Oh, yeah. All right. Okay, so this one doesn't look like it's a calculator one. Maybe, maybe not. Okay, but if from 0 to 2, we're at 2. Okay, so and then from 0 to 4, we're -3, and then 1 to 4, we're what? Okay, so in this type of problem, we want to make sure we can break apart our pieces. So we're told that I'm just looking at a function. Okay, it says 0 to 1. We're saying that's 2, whatever it is. But if I go from 0 to 4, we're -3. Okay, so what is it from 1 to 4? Now, I want to break this up into pieces. I want to break this apart. This is the integral from 1 to 4 of 3f of x plus 2. Now, if you remember for derivatives, we can break these apart. So integrals, we can break these apart. So this is really the integral of 1 to 4 of f of x, and I'm going to move 3 in the front, plus the integral from 1 to 4 of 2 dx. So this is the part that we have to be like way back when it comes to integrals. You can separate integrals, take away the constant. We can, if we're adding integrals, really, we're actually adding them outside. Now, can we figure out what this guy is here? Well, if we look at this part here, from 0 to 4, we're -3. And if we are 2 here, what do you think this section here has to be? So we can end up with -3. 2 plus x equals to -3. X is?
-5.
Yeah, -5. So we know this is -5 here. -5 times 3. And the integral of 2, that becomes 2x, plug in 1 to 4. So it's 8 minus 2 is 6. So plus 6. 15, so -15 plus 6 is -9. This is legit like a puzzle, right? So we can play around with that. So whenever you have problems like this, maybe mapping it out might be helpful. But I was trying to grab my brain around, what did they give me? They gave me from 0 to 1, we said that was 2. And they gave me from 0 to 4, that's 3. Well, they want 1 to 4. Fine, 1 to 4 here has to be -5 for us to get to -3 at the very end. So we know this integral here is going to be -5. This 3 here was throwing us off, but remember constant multiple means I can move it on the outside. So that's why we have the 3. We just kicked it out. And the plus 2, 2, that's my function. What's integral of 2? That's 2x, and then we plug in the 4 to 1. Let me show you what that means. Here the graph is 2, right? So what is the area between 1 and 4? Well, that's 3 times 2, right? That's a box. 3 times 2 is 6. That's 6. Sure, Bobby. Andrew, make sense?
Yes, thank you. And that clarifies a lot for me.
Yeah. See, these for me have always been like, you have to wrap your head around it. And the way you do it is just, you try to figure out what they want with what you have. So I only have from 0 to 1 and 0 to 4. They don't give me what's 1 to 4. So it helped me map it out. And this part was purposely there to mess you up because they wanted you to break up the function. Okay, I was asked to do number 4 right before that. Very similar question, very similar question. Okay, so they gave me, okay, so I'm gonna draw my simple number line here, just to keep my brain ahead of things, from 0 to 3, and then from 3 to 5, okay? So from 0 to 3, they told me this was 6. That's the area, the cumulative change. And then from 3 to 5, they told us that was 4. So they give us this new one, which isn't the function. It's made up of a bunch of stuff going on here. So to break this up is the integral from 0 to 5 of 3 dx plus taking out the 2 because it's a constant from 0 to 5 of f of x. Well, over here, if I want to say what's the function integral from 0 to 5 of f of x, well, that's adding up 6 plus 4, that's 10. Fine, we got this as 10. So 2 times 10. And the integral of 3 is 3x. Plug in 0 to 5. That's 15 minus 0 plus 20 is 35. Mr. Ko, you're a genius. Yeah. I would say, I'm being really sarcastic here. I am relying pretty much 99% on this question to give me hints of what to do. Because if I just look at these numbers, if I just look at this is super confusing. And I'm trying to break this up in my brain to try to separate that out. No, I can't do that in my brain. So I had to write it out. Okay. All right. Any other questions you guys want me to work on right now? So remember the FRQ is posted, FRQ number 4, you guys can work on that. I gave you guys 2 new topics, so there will be a little bit of struggle there, okay? I did give you guys 2 new topics. Okay, if you guys have no more questions here, let's go ahead and look at your FRQ then. So this is your FRQ number 4. So you have a table graph. So we worked with tables before. They're gonna ask you the average. Number 2, so I'm gonna work on number 2 and number 3. Number 2 and 3, one's differential, one is, they're both like implicit type of equations, or we're gonna work backwards, okay? So I'm gonna work on these right now and see how far we can get. So consider this equation, and here are a couple hints I want to point out. We have dy, and then dx, okay? I want you guys to first notice these points. Find the solution y. How do we get from this back to y? Okay, so in your head, how do I go from dy dx back to y? We have to probably take the integral, right? So the way we do that is we're gonna go backwards by separating our variables, making sure x is on one side, y is on the other. So I move this around, it'll be e 2y dy is equal to 3x squared dx. And hopefully you guys feel like that kind of makes sense. We're getting x's on one side, y's on the other. And then as we take the integral to both sides, this should clean up. Now, for some of us, we probably forgot how to take the integral of this 2y part, right? So remember, that's going to be u substitution for us because we need to deal with that 2. If not, you can just write the 1/2 in front, e to the 2y. If you want, double check that. What's the derivative of e to the 2y? That's e to the 2y. The derivative of y is 2, and then a y prime if you want to call it that way. Or 2 and then dy, right? Which gives us back to our 2y. On the right side, that's just going to be 3x squared, which gives us x cubed over 3. This 3 probably cancels out with that 3. And we have to remember to write one more thing here. We have to remember to write plus c. So when we're done with this, we'll end up with 1/2 e to the 2y equals to x cubed plus c. Okay, I'm thinking that's what's going to happen. Now, they gave us an initial condition. Now, my personal thing is I like to just plug in my initial condition. They told us, if x is 0, then y is 1/2. Great, because I have an x and y. So I'm going to plug in 1/2, e to the 2 of 1/2 is equal to 0 plus c. See, I plugged in my x's and y's. 2 divided by 2 is just 1, so 1/2 e equals to c. My c is 1/2 e. So to rewrite the problem, we end up with 1/2 e to the 2y is equal to x cubed plus 1/2 e. Okay, that's how I would write it. Now, we are not done yet because they want us to solve for y. Find a solution for y. So let's go ahead and start moving stuff around. So to move stuff around, we gotta get rid of the 2. Then we gotta get rid of the e somehow. And then we gotta get rid of this other 2. Okay, we have a lot of things we have to get rid of in this problem. So let's get rid of the 2. That becomes a 2x cubed plus the 2's cancel out, leaving me just e. Then we're gonna take the natural log of both sides. Natural log both sides, and then we're gonna divide that by 2. That's it. So the rubric, though, is very specific that if you do not separate variables, you don't get credit for this. And if you forget the plus c, you don't get credit for this. But let's go ahead and look at the rubric, because the rubric is actually really helpful for us to look at this one. Let me screen share the rubric right now. If you look at this, you get 1 point. You literally get 1 point for separating the variables. If you push x and y to each other's sides, you get 1 point for that. Isn't that super awesome? That's a free point right there. And then if you get the antiderivative of the dy and dx correct, if you can do that, you get another point each. That's 3 points there. And if you just remember the plus c, that's 4 points. You can stop there and walk away with a nice, easy 4 points. If you want to get another point, hey, plug in the initial condition, plug in 0 and 1/2. That's another point. That you're at 5 points already. And then if you solve for y, that actually is another point. The reason why is because they asked you specifically to say y is equal to. Okay. The way they solve it is they solve for y first, and then they plug in their initial condition. So please be advised that's what they did. I normally don't want to deal with a c. I'll plug it in first, find what c is, and then I'll kick everything over. That's just how I do it. It's my own personal choice. Okay. go back to let me take over again over here. Anyone have any questions on that one? Okay. Now, if you look at the next question, let's look at the second part of that question. Oops. The second part is find the domain and range of the function. So if you look at it, when does the value not work? And a reminder is for logarithms, you can't take the log of 0, right? And you can't have any negative logs. So as long as this is positive, we're good to go. So for logarithms, let me say this again, for logs, you can't have it, so you can't take the log of 0 because there's no exponent that would bring you back to 0, and you can't have a log of a negative number. Okay, so those are the values that don't work. So one thing we can do is we can first find when is it equal to 0. So our problem was y is equal to 1/2 natural log of e, sorry, not e, 2x cubed plus e. This sounds like so algebra 2, but when does 2x cubed plus e, when does this guy equal to 0? That's an easy way for us to solve for it. Okay, so if we solve for it, we can say move the e over, divide the 2, it'll be x is equal to e over 2, and then we take the x is equal to the cube root of e over 2. Okay, and as long as we are greater than 0, right, if you want to stick a greater than sign there, greater than 0, that's our domain. So we're greater than this value. Oops, I forgot the negative. There's a negative there. And then the range. So if we stop here, we already have 2 points. And then the range. What type of graph is natural log? A natural log graph, it looks like this, right? That goes from negative infinity to infinity. Okay, let's look at the second problem that looks similar to this. Let's see if we can just break it down to see if it's very similar to the steps. If you consider the curve, they give you x y squared minus x cubed y equals to 6, then show that this here, show that this is this. That's what they're saying. Show that when I take the derivative is this. So they just want you to take the derivative of it. Remember, you are going to be doing implicit differentiation. So the derivative of y is y prime. Or if you want, you could say the derivative of x is dx, right? The derivative of x is dx and derivative of y is dy. Or you can say the derivative of y over dx is just y prime. You can do that also. Both of these are okay. So just remember, you have a product rule here, you have a product rule here, things that you just want to be aware of. Okay. So you can play with that. This part here, find the curve whose tangent line is vertical. What does it mean when the tangent line is vertical? It means we're dividing by 0. So we want the denominator to be 0. So just when you're doing the problem, you'll say, hey, I want the bottom to be 0. That would be a vertical tangent. Look at some other questions here. The function f is differentiable at all. So this one is a differential equation again, no calculator. We are given a point 3 and 1/4 is on the graph. And then we have a slope at each point is x and y on the graph given by this equation here. Find the second derivative. So how do I get from, so a lot of these questions when we first are given them, they give you an easy part and a hard part. So how do I get from this to this is we just take the derivative. When we take the derivative, be aware that that's just going to be a product rule. And the derivative of y is y prime, right? If I take the derivative, or you can write it as dy over dx, whichever way you prefer. Both ways are okay. If you guys want me to do it, anyone want me to actually take the derivative right here, just as an example? Do you guys got this?
Yeah.
Anyone in the chat want me to take the derivative? You got this. You guys can try yourself. But it really is just the chain rule. So if I take the derivative of d over dx, that's why it's d squared y over dx squared. And then if I take the derivative, just product rule, 2y, y prime, leave the back alone, plus the derivative of the back, which is negative 2, leave the front alone, right? And then what you're going to do is, all these problems, you're going to plug back in that y prime here. So that is the hint. We're going to plug back in that y prime. So it's going to be 2y, 6 minus 2y, 2x, I'm sorry, 6 minus 2x times 6 minus 2x plus, whoops, I miscopied it, I'm sorry. We're going to copy the whole y prime, y squared, 6 minus 2x, 6 minus 2x plus minus 2y squared. Okay. Now, if you leave it like this, will you get full credit? Yes, you will. You get full credit because you don't have to multiply stuff together. You don't have to call that a squared. You don't have to say that's y cubed. Okay, that is perfectly fine. If you mess up on, so that's worth 3 points right there. And then they want you, no, 2 points. And then they want you to plug in the x and y. Plug in the x and y. Plug in x and plug in y. Plug in y. Now, please be advised that when you plug it in, you just have to write 2 parentheses 1 over 4. 1 over 4 squared. Cosine 6 minus 2, 3. 6 minus 2, 3. Minus 2, 1 over 4 squared. If you write it like that, leave it alone, you are good. Please, you can just leave it like that. That's perfectly fine. That's your answer. Because they don't care that you can add and subtract. Oh, you can multiply 1/4 by 1/4. Okay, they don't care about that. Okay, so you can save yourself time not having to do that extra step. And then, okay, all right. The second part is find y by solving the differential equation. So we're going to go backwards. And for this problem here, we just did this problem, right? You're going to separate our variables, move the y over, keep the x's on one side, and we're just going to go backwards with the initial condition. So we just did that in question number 2. So you guys have to practice that again. Hopefully it becomes pretty easy for you guys. Sometimes the tricky part is when you have to deal with natural log or exponentials. But this is a lot of this stuff is algebra 2. Last one is our related rates. So we're given a equation rate. That's our rate problem. So related rates, because they're rates. We take the derivative of rates. This equation RT represents speed in kilometers per hour at which the car travels along a straight road. The number of liters of gasoline used by the car is given by this model G of X. Okay. So we have a rate of speed and the amount of fuel used. Please notice that one is in X and one is in T. So that's a part that I'm very concerned about. One is in X and one is in T. All right, one is in X, one is in T. That's T and that's X. So how many kilometers does the car drive in the first 2 hours? Okay, so is that going to have to do with the number of liters used, or is that having to do with the rate? Which equation are we going to be looking at? Okay, so they told us kilometers per hour, right? So this is the equation that we're going to use for part A. And it's just simply, we're just going to sum up our kilometers using an integral, easy peasy. And that's all calculator work. This is a calculator problem. B, find the rate at which respect to time of the number of liters of gasoline used by the car when T is equal to 2 hours. So we have our second equation here. Now, here's the problem. They want with respect to time, okay? Now this is the hard part. They want us to say how much fuel we use.
Mr. Ko, it's 11:20.
Oh, thanks. Sorry about that. Anyways, so this one is actually, there's a trick to it. You're gonna try to find GD over GT, and this is, you're gonna do 2 things: GD over DX times DX over DT. You're gonna take the derivative of them both. Okay, well those are the rates, and you're just, the dx's cancel out, and you just end up with this new equation, dx over dt. Okay, and then you're just gonna plug in the number 2, and you're done. Okay, thank you very much. If you guys have any more questions, I'll see you guys on Tuesday. If I'm not here on Tuesday, please, I might not be here on Tuesday. I have an